Hello everyone, for my interesting math project presentation, I will be presenting the topic Sieve of Eratosthenes. First, in order to properly understand the Sieve of Eratosthenes, we must discuss basic concepts. The Sieve of Eratosthenes is pronounced Sieve of Eratosthenes. A prime number, which is very important, is any number that is only divisible by itself and the number 1. A composite number is a number that has more divisors than just itself and the number 1. A sieve is a tool that's used to separate certain elements from each other, typically used in cooking. However, in this situation, we will be separating prime numbers from composite numbers. First, let's look at some history of Eratosthenes. Eratosthenes was born 276 BCE in Cyrene and died 194 BCE Alexandria, Egypt. He was mostly known for being a Greek mathematician and a geographer, but he was also a well-known poet, philosopher, astronomer, and music theorist. The word geography, meaning writing about the worlds in Greek, was actually first used by Eratosthenes. The Greek mathematician also created an important math tool known as the Sieve of Eratosthenes, today's topic, which is used to find prime numbers within a certain range. He had numerous accomplishments as an esteemed geographer and mathematician. In 240 BC, he was able to use the angle of the sun's rays to calculate the Earth's circumference within a considerably accurate range. This was a huge impact on the math world back then, considering the amount of human intellect there was. He was the first to also recognize that the Earth is a sphere. In addition, he was the first to calculate the tilt of the Earth's axis relative to the equator and the distance from the Earth to the moon to the sun. Furthermore, the Greek scholar created the first map of the world that featured meridian lines and parallel lines, similar to modern-day latitude and longitude lines, as well as making a calendar that included leap years and became the foundation of chronology in the Western world. As you can see, Eratosthenes had many accomplishments that were extremely impactful upon the world. All of Eratosthenes' achievements as a scholar led him to being appointed to the prestigious position of director of the Library of Alexandria. Now let's actually talk about the Sieve of Eratosthenes. The Sieve of Eratosthenes is an ancient algorithm used to find prime numbers within a certain range. To first use the Sieve of Eratosthenes, you list all consecutive numbers within the range you choose and assign the first prime number as p, and after each round you assign the next following prime number. Starting with p squared, you will eliminate the multiples of p following the algorithm: p times p plus 1, p times p plus 2, p times p plus 3, and so on and so forth. The process halts when the square of p is higher than the last number on the list. Every single number that has not been eliminated at the end are identified as prime numbers. Now let's work the Sieve of Eratosthenes out. Here we have a number chart that ranges from 1 through 50, and first we'll cross off 1 as it is neither a composite or prime number because it has only one divisible factor. Now we will circle 2 to signify it as a prime number, and we will start from p squared, which is 4. And following that, we will mark off each remaining multiple of 2. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, and 50. As you can see, 2 knocked out many numbers. Our next prime number is 3. We will start from 3 squared, which is 9, and we will follow with the remaining multiples that are available. We start from 15 to 21 to 27 to 33 to 39 and 45. Those are all the multiples of 3. Now we move on to our next prime number, which is 5. We start at p squared again, which is 25. However, at this moment, we only have one more number to cross off, which is 35. Our last prime number is 7. And we only have one number to cross off for 7, which is p squared, which is 49. You see, we stop at 7 because 11 square is higher than 50. So therefore, according to that rule, we no longer continue the process. It looks like I made a mistake, and I accidentally circled 9. 9 is not a prime number because it is a multiple of 3. Now we circle the remaining numbers, which are 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, and that's it. Thank you so much for listening.